Hello everyone. My name is Khushi Jaiswal and I am third year student of SGSITS Indore IT branch. I am here to give a brief explanation on the topics prime and non-prime attributes and partial functional dependency. So let's get started in these topics in DBMS. So firstly we have prime and non-prime attributes. So prime attributes, basically speaking, prime attributes are those attributes which are a part of the candidate key, and non-prime attributes are those attributes which are not the part of the primary key. Candidate key. So to simplify this, I would like to add prime attributes are those attributes in a relation that are a part of any candidate key in the relation. See, the candidate key in that relation, the candidate key which we obtain in that relation, the primary attributes are those attributes which are part of that candidate key. These attributes are crucial for ensuring the integrity of the database as they help in uniquely identifying a record in the table. So candidate keys helps us to identify the records in the table uniquely, and since the prime attributes are part of that candidate key, so they help to identify the records uniquely in a table. And non-prime attributes are those attributes in a relation that are not part of any candidate key in the relation. See, candidate key here is very important. These attributes cannot independently contribute to the uniqueness of a tuple in a relation. Means since non-prime attributes are not the part of the candidate key, therefore they cannot uniquely identify the tuples, because candidate keys are the keys which are responsible for uniquely identifying the attributes, tuples, etc. But since non-prime attributes are not part of the candidate key, therefore they cannot uniquely identify. So we were discussing about these prime and non-prime attributes, and we came across a term known as candidate key. So what's a candidate? A candidate key can be defined as the minimal set of attributes that can uniquely identify a tuple in a relation. Means, see, the thing which I said, that these are the minimal set of attributes. There can be many super keys, but a super key uh, in which there is a subset, and that subset becomes the candidate key, then that super key is not a candidate key. Okay, so simplify this, we can consider it a table student. Here we have three attributes: enrollment, name of the student, and branch. So enrollment here is obviously the primary key because it is unique and it helps us to uniquely identify the tuples. So, according to this table only, we are not considering that in L branch there can be many enrollments, and in M branch also the enrollments can be same. But we are talking about only this table, not any other thing correlated to that. So, enrollment is a candidate key in the table student. So, it is a candidate key, therefore it uniquely identifies attributes such as names and what we have here, branch. Yeah. So, therefore, here prime attributes of student are enrollment because it is a candidate key. So, obviously, enrollment it is a part of itself. So, therefore, prime attribute is student enrollment, and non-prime attributes of student are name and branch. Means name and branch are those attributes which do not take part in the formation of the enrollment candidate key here. So, these are non-prime attributes. So, let us consider another example to understand this. See, suppose we have a relation R having these five attributes A, B, C, D, and E. है ना? Uh, yeah, here. So, and this relation has functional dependencies as these. C, A determines B, C and D together determine E, B determines D, and E determines A. So, here we find the candidate keys of R, because obviously for finding the prime and non-prime attributes, first we have to know what the candidate key of that table is, relation is. So to find the candidate keys, as we know, closure is taken. So here we have taken the closure of all five attributes, that is A, B, C, D, and E. So here from the closure of A, we can see that A can determine all the attributes. Like we have five attributes here, A, B, C, D, and E, and A can determine all of them. B can determine only two, like every attribute can determine itself. Okay, like here C, it can determine itself, D, it can determine itself. But apart from these, how many attributes they can determine? See, B can determine B and D here, and E, and similarly we have E here, and E can also determine all the attributes according to those functional dependency. So candidates key of R are these two, A and E. Separately they are candidate keys, not together. Like A and E together, it will become a super key then. A and E together, sorry, A and E individually are the candidate keys, because see, A can determine all the attributes and also E can determine all the attributes. That's the work of the candidate key. It can determine all the attributes in the table. So A and E are our candidate keys, and prime attributes of R are A and E, because A and E are candidate keys and therefore it has to be the prime attribute A and E. And see, non-prime attributes of R. Non-prime attributes of R are those attributes which do not take part in the formation of candidate key. So B, C, and D, these do not take part. See, we can see that if we subtract the set of prime attributes from the set of all these attributes, like these A, B, C, D, and these are five attributes. So if we subtract this prime attributes from that set, then we will get the set of non-prime attributes. Okay, here in this case. Okay, so here we are moving on to our next topic, which is partial functional dependency. Partial functional dependency in very layman terms. We can say that if a prime attribute determines a non-prime attribute, then this is a partial functional dependency. What I mean to say, see, it's a very good definition that a functional dependency X determines Y is a partial dependency if Y is functionally dependent on X and Y can be determined by any proper subset of X. In simple words, uh, a partial functional dependency occurs when there is a functional dependency between a subset of a candidate key and a non-key attribute. See very carefully. Here we have a subset of a candidate key. What are subset of candidate keys? We have discussed earlier. These are the prime attributes, and the non-key attributes means those attributes which do not take part in the formation of primary key. That is, sorry, candidate keys. That is non-prime attributes. So there is a functional dependency between prime attributes and a non-prime attribute. This means that the non-key attribute is functionally dependent on only part of the composite candidate key, not the entire key. See, not the entire key means only a part. Only a part means the prime attribute of that candidate key. Yeah. So consider this functional dependency. Here X is the determinant, Y is the dependent, we call them. So if X is a prime attribute and Y is a non-prime attribute, then X determines Y is said to be partial functional dependency. It's very simple. This has to be a prime attribute, this has to be a non-prime attribute, and if it is there, then it is a partial functional dependency. So, in partial functional dependency, the non-prime attribute is functionally dependent. See, Y is functionally dependent on part of the candidate key. Okay, so here X is a prime attribute, means it is a part of a candidate key. There must be some candidate key in which X is also contributing in formation of that candidate key. Therefore, it is a prime attribute and Y is a non-prime attribute. Here we go with an example. So we have a relation here R which has five attributes A, B, C, D, and E having these dependencies. A and C together determine B, A determines D, B determines D. Sorry, D determines B. Slip of tongue. So here we have taken the closure of all these attributes for finding the candidate key first of all. So here closure of A is capable to determine itself obviously, and B and C are able to determine themselves only. D is able to determine itself and B. So here we go when we take the closure of A. So we get that A can determine A, B and D. So we find that here A is alone capable of determining B. See here in the closure of A, we can see that it is capable of determining B. So A alone is capable of determining B without the help of any other attribute, which means B is partially dependent on AC. Like we have that functional dependent. I can't go back that recording actually. So we had that functional dependency. Just a moment. Yeah, we have that functional dependency, AC, which was determining B. So B is partially dependent on AC because A here is capable of determining B and A alone is capable of determining B. And so here we have discussed this partial functional dependency and where it comes in DBMS, in the study of DBMS. It usually comes in normalization. See, in normalization for a relation to be in second normal form, we say there are mainly six normal forms: first, second, third, BCNF, fourth, and fifth. Yes. So in the second normal form, if a relation has to be, see, there is a condition for a relation to be in second normal form, it has to be in first normal form. And what is the other condition? That it must not contain any partial functional dependencies. Means there should not be any functional dependency in the relation in which a prime attribute is determining a non-prime attribute. This is meant by partial functional dependency, and it should not be there. Then only we can say that the relation belongs to second NF. That is second normal form. So here we come to the end of this video, and I hope that all the viewers must have got a basic idea of what prime attributes are, what non-prime attributes are, and also what partial functional dependencies are, and how they play a role in normalization. And also I've tried to cover some more basic concepts like candidate keys with some examples. Thank you for watching everyone, and I hope that I was able to clear your understanding on these topics. Thank you.